Okay, so we want to use some rough estimations, some Fermi techniques, to figure out how tall a stack of dollar bills that was as much as the national debt would be. Okay, so our first estimate, national debt. So we're going to estimate our national debt at being $10 trillion. So 10 trillion, let's see, so millions is 10 to the 6th. Billions start at 10 to the 9th. So trillions start at 10 to the 12th. And so 10 trillion equals 10 to the 13th. Okay, so now let's do our next thing, which would be so let's use metric system. So how many dollar bills stacked up to make a meter? Okay, so think about it. So maybe you're thinking 100 bills to an inch times 36. So is it more than 1,000? So we're going to say 10,000. Okay, so we'll say 10,000. Okay, round to 10,000. So that's 10 to the 4th. Okay, so now if we divide, okay, and so now what would our crazy estimate be? So a crazy estimate would be, so before we really think about this, so I'm going to estimate the stack to the moon. Okay, to the moon, which is, I don't know, I think it's 500,000 kilometers. Okay, so let's see what we get if we do this estimate. So we're going to say, so now we divide amount of national debt by 10,000 $1 bills per meter. Okay, so that's going to be 10 to the, so we can get Fermi to do this, we can get Wolfram to do this for us. Okay, so we'll just say divide, and what are we going to put in? Let's see if we can just write it in. 10 to the 13th. And you'll see that it is just subtracting exponents. So if you haven't done this, let's see what we get. Yeah, so we get 10 to the 9th. So we get a billion, so it's just equal to. So in other words, a billion meters. Okay, but we want kilometers. km. So we divide by 10 to the 3rd. We divide by 1,000. Okay, and what's that going to do? Just remove 10 zeros. Just remove 10 zeros, remove 3 zeros. So our estimate is 1 million meters. 1 million meters, and sorry, 1 million kilometers. Okay, and now let's see if we can add in here. Let's just search real quick. Distance to the moon in kilometers. And so it is 384,000 kilometers. So just put that into our look. Okay, so distance to the moon in kilometers. Okay, so now try for more exact information. Okay, so we're going to go and grab from this the usdebtclock.org. So it's a great site to go to. Okay, so we're going to go there. When we go there, we just grab this piece here, which is what is our national debt. You can see it's going up by, well, it doesn't take long to go up by $1 million. If you just sit and watch here, we'll go from 350. So 27,776,350,000,000. Okay, and it's going to go up to 351 million. Okay. So that's kind of scary, isn't it? So then that's the amount that you owe. And so we'll look at some of the other statistics there in a minute. But if we go to a new line, we see that our debt is 27 trillion. Okay. And so then the other thing we want to know is how thick is a dollar bill? And it turns out that thickness is, so there's 100 dollar bills should be about ½ an inch. Okay, so if we were going to write out this as a conversion, let's see if we could do it. So we'd say, we can just write it. So 28 trillion times 0.043 inches per $100, right? Okay, and then what do we have to do with that? So we take our inches, and we could say, oh, and you could say times 1 meter for every, I think it's about 39.37 inches, that's how many meter, and times 1 kilometer per 1,000 meters. Okay, so let's see if we can do that calculation. All right, so try that in Fermi. So it would be what? It would be so when you look at it, you say it's going to be 28 to the 10 to the 12 10 to the parentheses. So it's 28 times 10 to the 12 times 0.0043 and Actually, we can just do this divided by 100, right, times this. So we can do it sort of like we've done our and then we're going to do times 1 divided by 39.37. So if this works in Wolfram, times 1 divided by 1,000. Okay, so that seems a lot different. So let's see if so that is a mere 30,000, so it wouldn't get us to the moon at all. So I'm not sure about that, but that's our calculation. So it could be that the 10,000, so let's just look at that and see. So up above we made, we assumed 10,000 bills per meter. Okay, and let's see what we have instead. So instead, let's estimate as well. So we have 1/2 inch equals 100 bills, $100, and so then a meter is about 78 inches. That's so 78 inches, so 150. So 15,000 bills per meter. Okay, so 15,000 bills per meter. So maybe I've got some mistake in here. So let's try again. So let's just try a little bit more. So we'll say 28. So we'll say we'll do a division of and what can we do? It times. So we'll do the whole thing. Times. And then we'll do it times in the power. 10, 12. Okay, so there's our times. And we're going to divide that by so we say 15,000 bills per meter. Okay, so that's it. So there must have been a mistake up here. That seems like we have much in this one. So that seems like a much more reasonable thing. So it's saying we had so that's like 5 billion meters. It should be 100, yeah. So you can see I'm struggling with this as well to do it. It's a very big number though. So the 28 trillion. So here we go. So 28 trillion divided by, try one more time. So basically we're going to say, so 28 trillion is 2.8 times 10 and 13 to the 13th, right? 10 to the 12th is trillion, so these are 10 trillions. Okay, and we're going to divide by, so we're going to say 15,000 bills per meter, but times 1,000, so 1.5 times 10 to the 7th, right? So we're going to say it's going to be 15 million bills per meter, which is 1.5 times 10 to the 4th, right? So 15 times 10 to the third, 1.5 times 10 to the fourth. Okay, so what does that equal? So it equals about 1.7. So we just divide 2.8 and 1.5 times 10 to the 9. Okay, so billions. So 1 billion kilometers. Okay, so it's a really big amount. So we were wrong, and I was wrong what I had before. Okay, and I underestimated